Physics review for the major quiz 3.2. Main subjects are work and power. So go through your notes and we'll talk a little bit about things here. What do things stand for? I'm going to do selected problems. For instance, this is potential energy. And energy is given in joules. M stands for mass in kilograms. G is a constant, so it's G equals the gravitational constant. And it is 9.8 meters per second squared, the acceleration which all things on Earth fall. Height, h, given in meters. So you can go through all these and do them on your own. The last one is the same. This is power. And I'll leave you to figure out the units. This is also power. And it's just energy. Any kind of energy that's being generated over a set amount of time, you can get the power. So this, of course, is time. And again, I'll leave the units up to you guys. So, is work done or not being done? Use a force to drag something along the ground. Now we're going horizontally, which is not against gravity, but we are generating a force to go a distance. Therefore, work is done. You pick something up off the ground, work is done. Lift something up over your head, work is done. If you're just holding onto something, no work is done. You're holding something while you're walking, no work is done. Now we actually generate a tiny bit of force between our feet and the ground, but not enough to make it truly doing work. It's inconsequential. I'll leave the rest for you. These problems, you will see these. What happens to the amount of work when the force exerted is the same, but the distance is doubled? Well, the first thing I'm going to do is this. So the force is the same, but we're going to have double the distance. If this goes up times 2, then the work has to go up times 2. So work is doubled. I'll leave the rest for you until we get down here. Lift the weight up 1 meter. What happens to the work you have to lift the same weight up 2 meters? Very simple. Work is force times distance. You lift a weight up, this stays the same. Distance goes up by 2, therefore the work has to go up by 2. Work doubles. I'll let you do the next one on your own. Potential energy, which has higher potential energy? 50 kilogram person at the top of stairs or 75 kilogram person? Well, energy potential is mass times gravity times height. Always the same, unless we end up on the moon. Same. So we just increase this, and actually it's 1.5. So times 1.5, therefore this is going to be times 1.5. So 75 kilogram is higher. Leave the other one to you. Kinetic energy, this is where things get a little bit more complicated. First one's not. Which has more kinetic energy? 1,000 kilograms or 10,000 kilograms if moving at the same speed? Well, the energy kinetic is 1/2 mass v squared. If v is the same, but the mass goes up, then this will go up. So the 10,000 kilogram truck has more. Now, this is where life gets challenging. If the speed changes, for example, here we have a runner. What's their kinetic energy? Well, this didn't change. But the velocity does. Well, velocity goes up by 10. We have to square it. Then the energy goes up by 10 times 10, also known as 100. Very challenging. Power, got to crank them out. You lift 1,000 newtons for 10 meters. Friend lifts 1,000 newtons by 10 meters in half the time. So let's make up a time. It takes you 10 seconds. Half the time for them. Takes them 5 seconds. Who does more work? Well, work is just force times distance. That isn't different for either one of these, so it's the same. 1,000 newtons times 10 meters. You both do 10,000 joules of work. Same. However, since your friend does it in half the time, friend has more power. To see that, we have to come out here and do power equals work divided by time. It's the same for both of you. So for you, it's, pardon me, the work is the same for both of you. 10,000 over 10 equals 1,000 watts. For your friend, it's 10,000 over 5, which equals 2,000 watts. So you can see your friend has a lot more power. It's a good way to solve these problems. If you get confused, just pick some numbers out and plug them in, see what happens. Leave the rest for you guys. This is a big one. I put it in bold. Energy potential is mgh. And weight is just the first part of that. Weight, and we've discussed this before, but a lot of people have forgotten, is mass times gravity. So if you weigh 100 kilograms like I do, G is always 9.8 meters per second squared. Your weight is 980 newtons. And this is why we have kilograms in meters per second squared and newtons in metric, but doggone it, in English units we only have pounds, and in mass and weight tend to mean the same thing, even though they do not. I'll leave these for you. Let's try one of these. Pitcher does 100 joules of work on a baseball. How much kinetic energy did the pitcher give the ball? Well, if we go back to the equation that work equals force times distance equals joules of energy, we can see it's kind of a trick question. They gave all of that to the ball in kinetic energy, 100 joules. Energy created by work equals energy either in potential or kinetic. Since the ball's just flying along, it's a foot or two off the ground, and has a little potential energy, but let's assume that the pitcher was holding it there in the first place and didn't add that potential energy. Then it gave 100 joules of kinetic energy to the ball. So this is the lab you did. How much work did Fran do? 65 kilograms. Work equals force times distance. In this case, the force is 65 kilograms times 9.8 meters per second squared times the height of the bleachers, 2.24 meters. Multiply it out. You get 1,000, well, around 400 work joules. So that's how much work they did. The power, since it took Fran 2.5 seconds to get up, work divided by time, 1,400 joules over 2.5 seconds, 560 watts. One more. Jamal pulls his brother on a sled for 50 meters and does 2,500 joules of work. How much force? Well, work is force times distance. He did 2,500 joules worth. I don't know how hard he was pushing. He did it over 50 meters. So we want to get F alone. We divide by what's next to the F. You get force is equal to 50 newtons. How do I know joules over meters is newtons? Because it's force. Force is always newtons. That's it. Any questions besides this? Bounce me an email. Good luck.